Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to talk about how to find the area of a polygon using an apothem. So one of the things that we want to make sure that we understand is that any sort of polygon that we're looking at is a regular polygon, meaning all of the sides are going to be equal, all of the angles are going to be equal. One of the other things that we're going to need to remember is that whenever we're looking for an area of a polygon, using that apothem, my area, or I guess I should do area, is always going to be 1/2 times the apothem times the perimeter of the entire shape, right? So for example, in this particular image that I have here on the screen, our goal is to find the area of the shaded region. So we're going to make a pretend that all of my sides and angles are the same. We're also going to make pretend that all of my shaded regions are the same, because we know that if all the chords are the same, all of the distances between the chord and the actual outside of the circle are going to be the same distance, right? Not kind of like what I have here, but that's okay. I'm just, really amazing at drawing things properly. Okay, so then the other thing is, in order for us to find the perimeter, we know that we can just take that, hey, this side length is 12. So that means all of these side lengths are going to be 12. So my perimeter is going to be 12 times 5 because it's a 5-sided shape. The next thing, so that's 60. The next thing that we want to make sure that we know or make sure that we find is the apothem. I'm going to change my color really quickly just so we can understand. The apothem is not this. This is actually the radius. The apothem goes from my center of the circle straight down in this 90-degree angle to a chord. Okay, so what happens is that this little blue triangle here, it's actually a right triangle, and I'm going to redraw it here because what happens is this is going to be one of my 90-degree triangles. Now it's either going to be a special right triangle, like a 30, 60, 90 right triangle, or it'll be a different kind of right triangle. So how do we find the angles in this triangle? Oh, I wonder why my thing is kind of funky. Okay, here we go. In order to find the angles in this right triangle, what we are going to do is we're going to actually open up a calculator and we're going to put in, hey, this is 360 degrees, but in order to see all of my angles, I just want to make sure that we're clear on where these angles are and which angles we're looking for. We're looking for these angles here. Ideally, we're looking for these angles, but if we can divide 360 into multiple angles, we're actually going to look at this 5-sided shape, right? So I'm going to take my 360, I'm going to divide that by 5, right? We get 72, and then we're going to divide that into 2 equal parts, making this angle right here a 36-degree angle, right? So these 2 angles here, those will both be 36-degree angles. So sometimes when they're not perfect right triangles, we're going to have to use some form of SOHCAHTOA in order to find what the other measurements are. One of the things that we know is that this total length down here is actually 12 units, right? And we know that because we used that for our perimeter, we used the 12 and then we multiplied it by the 5. So technically we know that this side here is the same as this side here. So this is a 6, it's 6 units, I guess. So they didn't give me units in the question when I redrew it. So we're just gonna go with 6 units. Okay, and because we're looking for the apothem, this is kind of like our question mark. This is our X, this is our unknown. So you will need a calculator in order to solve this problem. I would recommend a graphing calculator, or a scientific calculator. You can always use like your iPhone and turn it sideways, whatever you have, so long as you're capable of doing sine, cosine, tangent on that calculator. Or you can just use like the chart with all of the numbers, and then that's going to be like a little bit crazy pants. So I would not recommend that, but a calculator for sure. Okay. So in this particular case, I know that in relation to this 36-degree angle, I have my opposite side and I have my adjacent side. In order to find a trigonometric function using opposite and adjacent, I know that's going to be tangent. So I'm going to go tangent of 36 degrees, and I know that's going to be opposite over adjacent. So really I can replace this with equals 6 over unknown or x, right? And I can actually find the tangent of 36. Now, some calculators you can like plug in 36 and then click tangent. Some of them you might have to click tangent and then 36. So it just depends on the type of calculator, just be aware of that. So when I found the tangent of 36, I ended up with 7.265, let's say. 6 over x, and then I know that I can create two fractions and set them equal to each other, and I'm going to end up with 6 equals 0.7265x. Divide both sides by 0.7265, and then let me just get that on the calculator. So that should be 8. It says 8.2583 if we round it. It really does depend on what the question asks. You know, are you being asked to round it or to the nearest tenth, to the nearest whole, to the nearest whatever? So we can put that number in, like either this one with 4 numbers after the decimal point, or you can leave it in the calculator and hit times the 60, which is the perimeter, and then times a half, which is 0.5, and then you would end up with the area is, so I would do 1/2 times whatever this 8.2, yikes, but like whatever it was on the calculator, and then times 60, and then I should end up with 247.75 square units. Now, this is the area of the entire polygon, meaning this is the pentagon, that's the area of the pentagon, that's the area of that white space in the center of the circle. However, we're not being asked to find just whatever is the center of the circle. We're being asked to find that shaded region between the shape and the circle. So what's happening is I now need to also find the area of a circle. And we know that the area of a circle is going to be pi r squared. And we actually need to find the radius. The radius is always from the center of the circle to the edge of the circle. Now, the reason why I bring this particular radius into view here a little bit more is because this is the hypotenuse in this same right triangle. So in addition to using the trig function of tan, we're also going to use maybe opposite over hypotenuse, which is sine. So I'm going to go in and I'm going to go sine of 36 is going to be opposite over hypotenuse because of SOHCAHTOA, right? And then that's going to be 6 over, again, my question mark. So then I'm going to go into my calculator. I'm going to find sine of 36 degrees. That's going to be 0.5878 equals 6 over x. Put this over 1. Again, do that same business, right? So I'm going to end up with 6 equals 0.5878 x. Then I'm going to divide both sides by this 0.5. Whoops, see there's 8. Okay. So let's do that and then divide it by that. And then we should get x is about 10.2078. Yeah, that's enough. Four numbers after the decimal point. Okay. So that's my radius. Now I can go in and multiply that by pi and take my radius and square it. So I'm going to go in, I'm going to square that. I'm going to multiply it by, If you have a pi button, you use the pi button. If not, that's fine. And then that area is going to be about 327.35, again, square units. We're going to hopefully make sure that that works. I know this is kind of like a lot. There's a lot of tangent signs. There's a lot of work happening outside of the calculator. So just be aware that that's something that's going to be super important as you work through the process, okay? You want to give yourself enough space. If you've got like a few lines left on your page, definitely that is not enough space. As you can tell, I'm writing all over the screen. Okay, so now my goal is to make sure that I can actually go in and say, hey, this is my area of the entire shape. This is my area of just the pentagon. Now I need the area of the shaded region. So I'm going to go in and I'm going to take this 327.35 and subtract 247.75. And I'm going to end up with, I should probably not write in pink highlighter, my final answer. I'm going to end up with 79.6 square units. That should be how I find the final answer. Now, if you have an answer key to this problem, this is again from the Big Ideas math book. It's the geometry high school book for Common Core State Standards. This is section 11.3. It's just finding the area of the shaded region using the apothem. If you're looking at the answer key and it's 79.59, obviously I've rounded, I've done a little bit of different math, right? So my rounding may be a little bit different than what they're doing. They might just use 3.14 versus pi. So if you're in about this 80 square units, I think we're in a good place, okay? Understand that you will likely, if your questions on a test are multiple choice, you'll likely see the right answer. You're also paying more attention to, oh, they wanted, 2 numbers after the decimal point, 5 numbers after the decimal point, whole numbers only. So you'll see a little bit of a difference, okay? All right, so here they actually give me, it's the same kind of question, find the area of the shaded region. So we know we're gonna need the area of a polygon is gonna be 1/2 the apothem times the perimeter. We know we're gonna need to find the area of the circle, and that's going to be pi r squared. And in this particular case, they already gave me the radius, so I'm just going to do that real quick. So that's going to be 8 squared times pi. So 64 times, where's my pi button? So I'm going to leave that as 201.06 square units. Again, they didn't really give me units, so it is what it is. So that's going to be one of my important numbers. And then I'm going to subtract the area of the triangle from this particular area of the circle. In this particular case, in order to find the apothem, and I'm going to go ahead and change the color again, I need this triangle here. Now, one of the things that I know is that my apothem is always going to create this 90-degree angle. And I also know that my circle is going to be divided into these 3 main circles, right? So if I take 360 and divide it into 3, sorry, not circles, into 3 big angles. If I take 360 and divide it between those 3 angles, I'm going to end up with 120 per angle. And then when I take that and divide it between those 2, I'm going to end up with 60. So here's what my triangle is going to look like with this being 60 degrees. And now we know that we have a 30, 60, 90 triangle. So in the later chapters of any sort of geometry, algebra 2, any sort of math lesson that you're taking now, the teachers in the math books are assuming that you remember and you've retained all of the information up until this day, right? So using, if you're in chapter 11, they assume chapter 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then algebra 1, because that comes before geometry, and then pre-algebra in middle school, and then all of these previous classes, they assume that you have retained this math. And they assume that you are capable of applying the math that you've retained into this current problem right now, okay? So if you don't remember trigonometric functions, if you don't remember your special right triangles, definitely go back and definitely refresh your memory on those, because you will need them for this particular chapter, okay? All right, so we also know that in this 30, 60, 90 triangle, you know, I've gotten off my horse, right? We also know this 30, 60, 90 right triangle. We've got, this is n root 3, and this is 2n. So because I know that the radius is the same thing as the hypotenuse because it's opposite this 90-degree angle, I know I'm going to set that equal to 8. That means that n is going to be 4, and my apothem is 4. So in this case, my area is going to be 1/2 times 4, which is my apothem, times the perimeter. And the perimeter, because this is a triangle, it's going to be 3 times whatever the base of this triangle is, right? Well, if n is 4, this is going to be 4 root 3. But remember, we're only dealing with half of this right triangle that's right here. So this portion from here to here is 4 root 3. That must mean that the entire portion going from the from one vertex of the triangle to the complete opposite vertex of the triangle is going to be 8 root 3, right? Because I'm doing 4 root 3 plus another 4 root 3. So because it's a right triangle, because it's a triangle, I have 3 sides. So 3 times 8 root 3. One of the things that I can do is I can actually simplify this and end up with 2 times 24 root 3, because I just did that math here. And then I end up with 48 root 3. 48 root 3 is the area of the triangle, okay? Now, if they're asking me to round my answer to the nearest whole number, I know that I could just do 48 times root 3 and figure out what that whole number is and subtract that from 201, right? Because again, that 48 root 3 is just the triangle. So I'm going to go in and I'm going to do the square root of 3. And I'm going to multiply that by 48 in order to figure out the answer to this, right? So this is actually the same thing as 83.1, let's call it 4 units. Okay, so I have 201.06, right? And that's my area of the entire circle. And I'm going to subtract 83.14, which is the area of the triangle. And I'm going to get a total of 117.92 square units. And that's the area of my shaded region. There are other problems in this same book. I would recommend you trying them, or maybe you can just Google like how to find the area of a polygon using the apothem, something like this portion here. We want to make sure that you're capable of doing both the sine tangent piece and the special right triangle pieces. So maybe try some shapes that are like 4 sides or 5 sides or 6 sides, so that you can get a better understanding of what it is that you need to do. I will see you in the next video. Happy studying.